talking about laws of motion given by Newton. First, we shall be talking about forces. What a force is, how do we define force now in ninth grade. There are three laws given by Newton. The first law, which defines a new physical quantity, that is inertia. The second law, that is based on another physical quantity, that is momentum. And the third law that talks about action and reaction forces. The fourth law is a special law which is known as gravitational law. So in all, we shall be studying about forces as well as four laws that are given by Newton. How do we define force? Or rather, how did Newton define force? A force is an external cause that changes or tries to change the state of rest or of uniform motion of an object. That means, if an object is at rest, we can move it by the application of force. Or if an object is moving, we can stop it with the application of force. In short, a force is an external cause that will either change or try to change the state of rest or of uniform motion of an object. Remember, we are talking about motion in a straight line in ninth grade. Forces are of two kinds, contact forces and non-contact forces. Contact forces. All the forces that act on a body directly or indirectly through a connector are known as contact forces. For example, somebody is wanting to pull this box. They can either pull it by using their hands, or as you can see in the diagram, they are using a rope to pull the box. That rope is known as a connector. So any force that acts on a body directly or indirectly through a connector is known as a contact force. It can be a push or a pull, anything. While non-contact forces are the forces which act without any direct contact or a connector. They do not require any direct contact. Also, they do not require any kind of connector. Types of contact forces. There are four examples of contact forces that we shall be studying this year. Normal reaction force, tension in a string, frictional force, and force due to collision. While three non-contact forces, gravitational force, electric force, and magnetic force. Remember, non-contact forces are also known as field forces. Let us understand the contact forces first. Again, what are contact forces? All the forces that act on a body directly or indirectly through a connector are called contact forces. Examples of contact forces. First, we are going to talk about frictional force. You can see there is a man who is trying to push a box. Now, if I try to draw the direction of the force applied, this is the direction of his applied force. At the same time, there will be a frictional force acting in the opposite direction. But the frictional force cannot act until and unless that box is in contact with the ground. You can see both the forces are in opposite direction. There is an applied force which is acting towards the right hand side, and there is a frictional force that is acting towards the left hand side. And if the box is not moving, that means both the forces are balancing each other. Remember, an object does not move if both the forces are balancing. But if the applied force is more, the box will start moving towards the right hand side. So this is a contact force. Frictional force is a contact force. Another kind of contact force is a normal reaction force. If we consider a box lying on a table, there is a downward acting force on it, which is the force of gravity, which we consider it to be its weight. So we have a downward acting weight of the object, while at the same time from the surface of the table there is an upward acting force, which will be its normal reaction force. So if I draw the direction of the normal reaction force, it will be upwards. Again, the box is not moving because the two forces are balancing each other. The downward acting weight of the box due to gravity is balanced by the upward acting normal reaction force. Again, the normal reaction force is a contact force because it cannot come into action until and unless that box is not lying on the surface of the table. That was the second example of a contact force. Another example of a contact force is the tension force in a string. Again, if I consider this pendulum or anything that is hanging with the help of a rope or a thread, there is a downward acting force of weight of the object. Immediately, there will be an upward acting tension in this string. Again, there are two forces which are balancing each other. The downward acting weight of the object, let me write that. So the downward acting force is the weight of the object is balanced by upward acting tension force. Now, since these two forces are balancing each other, the object is not falling down or it is not going up. Again, tension force in a string or a rope or a chain or a link is always acting in the upward direction and it is a contact force. There cannot be tension force until and unless there is an object hanging with the help of these substances. So tension force is a contact force. Another contact force is collision force. Consider two cars colliding with each other or two objects colliding with each other. So there is a force of this car acting on this car. At the same time, there is a force of this car acting on this car. The forces are acting mutually. And if the forces are equal, after collision, both the cars will come to stop. Of course, collision force cannot act if there is no contact between the two objects. So collision force is also a contact force. Again, there are four contact forces that we are supposed to remember. There is this force of friction. There is a normal reaction force which acts upwards. Friction force acts opposite to the applied force. Normal reaction force acts upwards opposite to the weight of the object. Collision force, which is a mutual force acting on both the objects. Tension force, which is vertically upward acting opposite to the weight of the object. These are all contact forces. Coming to non-contact forces. Again, non-contact forces are the forces which act without any direct contact or a connector. They are also known as field forces because they are acting through a field. For example, on the left hand side, you can see the earth. Earth has its own magnetic field in which Earth has its own gravitational fields in which its gravity is felt. So gravitational force is a field force or a non-contact force. Similarly, at the bottom, you can see a magnet. A magnet has its own magnetic field. Even Earth has its own magnetic field. So this small magnet has its own magnetic field in which its effect is felt. It is a non-contact force. Anything that is coming into its magnetic field will be affected by it. Then there is an electric field due to a positive charge and due to a negative charge. Electric field is also a non-contact force. Electric force is also a non-contact force. It can act without contact. So three non-contact forces or field forces: gravitational force, magnetic force, and electric force. We come to the effects of force. Now we know that, coming back to the definition of force, we define force as an external cause that changes or tries to change the state of rest or motion of an object. So if anything is at rest, we require a force to move it. Or if anything is in motion, we require a force to stop it. These are the two important effects of force. Other than that, there are two more effects of force we should study with the help of examples. First one, a force will set a stationary body into motion. any stationary body or anything at rest can be put into motion by the application of force. For example, a ball is lying and I want to move it. The easiest thing is to kick it or to hit it with a bat. So a ball can roll when it is kicked. That was a stationary object that is put into motion with the help of the force from our foot. A force can stop the moving bodies. If anything is moving, we can stop it by the application of a force. For example, a cycle can be stopped when brakes are applied. Another example, if a ball is rolling, we can stop it by putting our foot in front of it. The ball would stop. In both the cases, we are applying a force to stop the object. Third one, to change the direction or speed of a moving body. Any object that is moving, its direction and its speed can be changed by the application of force. For example, when a bowler is bowling and a batsman hits it with his bat, the batsman will change the direction of the ball as well as the speed of the ball. Same thing happens in the game of football. One player is hitting the ball in one direction with one particular speed. If another player comes and hits the ball, the direction and speed of the ball will change. That's the third effect of force. Fourth one, to bring about a change in the dimensions of the object. A force will always change the dimension of the object. When we say dimensions, we mean shape and size of the object. This is particularly applicable to objects like sponge that can be compressed, a spring that can be compressed and elongated, a rubber band that can be elongated, Play-Doh or any kind of dough that can be compressed and its shape can be changed. So essentially, there are four effects of force. Number one, to set a stationary body into motion. Number two, to stop the moving objects. Number three, to change the direction or speed of a moving object. And number four, to bring about a change in the dimensions, that is the shape and size of the objects. Remember, we define force to be an external cause. Newton has defined force to be an external cause that either changes or tries to change the state of an object. The state can be either state of rest or it can be state of uniform motion. That was all about force. Next class, we are starting with Newton's laws.